In the last video, we understood what are mechanical waves, correct? Now, what the main important part is, now that you have understood what is a wave, how do we represent it mathematically? That means we are looking at equation of a wave. Alright, let's start with the mathematical part here. For this, we start with a very simple figure. Now here what we'll do, first we'll consider x and y axis. So for this x and y axis, let's say the wave is like this, a simple wave, right? This is the origin and this is the time t, this is the displacement y. Now in this one, what we'll consider some point p. Okay, in this case what you have is that, let's say we have some point here, let's say this point is p, and this point p is at the distance of x from the origin. Fair enough? We are looking at the position of this p from the origin. Now what is the general form of any these kind of functions? It's a simple harmonic motion, correct? That's how we described a transverse and a longitudinal wave. It's an SHM and the displacement whatever condition. It's an SHM basically. Since it's a simple harmonic motion, we can write, that is, see, remember we are talking about the initial part here. We have y of 0 comma t is equal to r sine omega t. R sine omega t. Now, why we write y of 0 comma t? There is a meaning for this one. Okay, when we say y of 0 comma t, that means we are taking a value of x, or in the sense you can say that the object is starting from origin. That's why it's 0 comma t. Alright. So this is the equation, y of 0 comma t is equal to r sine omega t. This is the equation of the wave. But remember, we are not still convinced that this is the equation, because there is a lot of different parameters which will be involved in it. So we have r sine omega t. Now what we do, we take the we consider the point p. So we can say, let p be a point at a distance of x from O, the origin. Alright. Now what you have? Now if you look at the origin and if you look at point P, there is something called as a phase lag. You guys know what is a phase already. In oscillations also we did phase. Now here, whenever we talk about phase lag, it's very easy to understand whenever we talk about phase. Okay. Now phase is what? A particle is moving, correct? Let's say a particle is moving, and then suppose if another particle moves after a period of time, then we say there is a phase lag. Now let me give you a simple demonstration for this one. More than demonstration, it's more like an example, you can say. Okay. Now in an example, see, suppose say you have one wave. Let's say I'm going to write the first wave, say like this. Let's say I have another wave. Instead of starting from the origin, let's say the wave started from here. You know, the wave goes like this. See, like this one. What I can say, look at the first wave. Say, see, this is the first wave and this is the second wave, correct? The first wave is reaching its maximum, then the second wave starts. Isn't it? In the sense, the second wave is lagging by some distance. Make sense? This whatever distance we are looking at, we call this as the phase. That means there is a phase difference. What we say in normal words, we say that they are out of sync. They are in sync, correct? So in sync meaning both of them are in phase with each other. When we say they are out of sync, like say a group of people are dancing, we say that they are out of sync. In the sense they are not in phase. So there is a phase difference. when we say they are in sync, it's it's in phase with each other. That means what we are looking at, like let's come down to the physics point of view now. When we say they are in phase, the two waves are in phase with each other, we say that the particle displacement is the same. Okay, so we are going to understand about phase in the next video. But for now, what is required for the derivation, point P, whatever you are looking at in the figure, now what you have is that point P is lagging compared to the origin, correct? That means we say that there is an important, so this is quite an important term. We use the term phase lag. Okay, point P has a phase lag. Now what we do, we are going to consider the phase lag in terms of the mathematical part. Fair enough? Now what we do is that phi value, phi is called as the phase. This is given by 2 pi by lambda into x. How we get 2 pi by lambda is the sense, see, look at the wave. This entire thing, so whatever you are looking from here to here, entire thing, this is one wavelength lambda. The total angle is 2 pi. Then we use the unitary method. Like for lambda, it is 2 pi. So for x, how much is it? So we use the unitary method and we are going to get this formula. Phi is equal to 2 pi by lambda into x. Now what do? You substitute. We try to answer this one. That means here, what we have is y, see, y of 0 comma t in this place, y of x comma t is equal to r sine of omega t minus 2 pi by lambda into x. So what we get here, why we write it as 2 pi by lambda into x? There is a phase lag. Since there is a phase lag, we write minus. Make sense? This is how we are going to write it. So r sine of omega t minus 2 pi by lambda into x. Okay, now the next thing what we have, omega, we'll write this as y is equal to r sine of 2 pi by t into t minus 2 pi by lambda into x. Take the 2 pi outside. So you have r sine 2 pi divided by, okay, I'll do one thing. Let's take 2 pi by lambda outside. Then this is going to become lambda by t into t minus x. Correct? So whatever we are looking at, see this lambda by t, lambda is the wavelength, t is the time period. Lambda being the wavelength, wavelength by time period gives you the velocity. That means here what we'll get is that y is equal to r sine 2 pi by lambda into vt minus x. This becomes one of the equations whatever we have for a progressive simple harmonic wave. Okay, so this you can say that it's a progressive simple harmonic wave. Okay, now there are other ways of representing the same wave also. Okay, there are other ways. Let's do another formula for the same thing and let's try to figure out what is the meaning of that. Another way of finding the equation of a progressive wave, we can take sine and cosine, because see, both sine and cosine are simple harmonic functions. That means we can write y of x comma t is equal to a sine of omega t plus or minus kx plus b cos of omega t plus or minus kx. Now here the k value, so k is called as the propagation constant. So propagation constant. Okay, and the value of k is 2 pi by lambda. Like whatever we did in just couple of minutes back. K value is that. Alright. Now since we have linear combination, this can also be used to express or represent a progressive simple harmonic motion. But in this, what do? See, we'll take the value of r, okay, some value r which is equal to root of a square plus b square, and the initial value of the phase, or what we call as the epoch. We can say phi naught is equal to tan inverse of b divided by a. Fair enough? Now, suppose in a longitudinal wave can also be described as SHM. If you have a longitudinal wave, then what we write is that, see, think about it like this. In a longitudinal wave, the direction of the displacement of the particle and direction of propagation, they are the same. In other words, you can say that they are parallel to each other. Since they are parallel to each other, the equation changes. Then the equation is going to become S of x comma t is equal to r sine omega t plus or minus kx plus phi naught. This is the value what we use, and this is very specific to longitudinal only. This is for longitudinal. Fair enough? Now, the equations of progressive motion, whatever we are looking at, the progressive wave, for transverse it's different, for longitudinal it is different. So here there are three major factors what you have to understand. Amplitude is one, the plus and minus part. Second is the angular frequency part, which is the 2 pi by t or 2 pi f part. And the third one is about the phase. Okay, the phi value. Phi naught is the initial epoch, or just the value of phi also you can take. So this is one of the characteristics of the wave, the equation of the wave. Let's understand different characters in the upcoming videos.